Hello, this is our submission for the Safe Bank Simio Simulation project. In this project, we are looking to simulate the transactions and conversions necessary to fulfill customers' demands. We're looking to minimize the excess funds in the bank to minimize the opportunity cost without running out of a specific currency. In doing so, we're looking to find the maximum profits from converting the currencies. Afterwards, we're looking to test the model in different scenarios to determine the validity. First, we have to break the system into components. The source, which is the client entry, based on the inter-arrival distribution. Next is the entity itself, which is to be assigned the average transaction amount. The servers are all the processes that are going to be done within the bank, which include separating the currencies, converting the values, monitoring the currency amounts, and then also resetting the currency values to when the minimum requirements are reached. Finally, we have the sink, which is going to be the endpoint of our model. We start by looking at the inter-arrival distribution. We found the distribution by entering the data into Arena. We found that the best distribution is the beta distribution. It had the lowest square error, so we decided to use that one. The graph looks a bit off, but that's just because most of the values are very close together, but it all works out when you have the model itself. Next, we have the currency amount distribution. We also used Arena to find this. We found that it was best fit by a gamma distribution. It had a very low square error, so we decided that this one is the best to go with. There are also some assumptions we had to make when doing this project. We assume that every week has similar transactions, no matter what time of the year it is. We also assume that all trading is done from 8 a.m. to 6:30 p.m. on every single day. We also assume that all 30 clients remain constant, meaning that no new ones are added and no existing ones are lost. We also assume that all the percentage fees remain constant. There are also a few limitations of this model. For the random distribution of transaction values, we had to use a constant average as opposed to a distribution for these values. The percentage fees are also not applied, so we're looking at just the raw numbers. Also, we only looked at the business as usual scenario, and the optimal currency amounts are undetermined, and we had no good way to model it in the system itself. So now we're going to be looking at the model itself. It starts with the entities coming out of the arrival time. Each one is being sent out according to the inter-arrival distribution. It then goes into the separator, which determines whether the customer is looking for USD, euros, or British pounds. It then goes into the converter, which is going to be looking at which currency they want to be converting to. Also at this point, it is going to be checked to see if CLS Bank has to give any more money to the bank. Afterwards, it'll go into the next part, which is checking the US dollars, the European euros, and the British pounds. Afterwards, it is going to be withdrawing the money from the pool that the bank has. And afterwards, it is going to the end transaction. Afterwards, it is also being checked to make sure that there is enough money. And if there is not enough money, then Global Bank will have to give the bank a bit more money, which goes all the way back to the beginning of the system. And that is our model to the best of our abilities. Even without having specific data points assigned to each client, due to the lack of knowledge of the program, you could still see how each client flows throughout the system and is affected by the servers in the system. And that is our project. Thank you.